this videotape, we will learn how to simplify complex fractions. A complex fraction is a fraction which contains fractions within its numerator or its denominator. For example, 1/2 plus 2/3 divided by 1/3 minus 3/4. Note that we have a fraction here. This is the numerator, this is the denominator, and within the numerator and denominator we have other fractions. This is a complex fraction. And we want to simplify this so that we wind up with just one numerator, a numerator without any other fractions, a denominator without any other fractions. Now there are two basic ways for doing this, and I will illustrate them both. Which method you use on a problem is sort of up to you. Okay, method number one. We handle the numerator and the denominator separately. First, we add the fractions in the numerator, combining over the lowest common denominator. And then we work on the denominator here. We find the lowest common denominator of these two denominators here. We add these fractions, and then we divide fractions by using the idea of inverting and multiplying. Okay, so let's work that out. 1/2 plus 2/3 over 1/3 minus 3/4. Okay, we're working separately with the top and the bottom. Now, looking now only at the top, we have two fractions in the numerator here. Two fractions, one with a denominator 2, one with a denominator 3. We're looking for the smallest number that 2 and 3 divide into, and that would be 6. It happens to be, in this case, the product of the denominators. The lowest common denominator there for the numerator is 6. We would like to build fractions equivalent to the two that we have here, which have denominators of 6. Okay, now we have the fundamental principle of fractions, which says you are allowed to multiply the numerator and the denominator of a fraction by the same non-zero constant, and you will get an equivalent fraction. Here we have 1/2. If we multiply the denominator by 3, we would get a denominator of 6 here. Okay, so if we multiply the denominator by 3, we have to multiply the numerator by 3 as well. 2 times 3 gives us a 6. 1 times 3 gives us a 3. 3, 6, that's equivalent to the 1/2. Now let's look at the 2/3. To go from this denominator to this denominator, from 3 to 6, we have to multiply by 2. If you're going to multiply the denominator by 2, you must multiply the numerators by 2 also. So 3 times 2 gives us 6. 2 times 2 gives us 4. 4, 6, which is equivalent to the 2/3. Okay, now don't reduce these. Okay, we had them this way. The idea was to get both of these fractions with the same denominator so that we can add them in the next step. Okay, now let's look at the denominator. 1/3 minus 3/4. The lowest common denominator for these two denominators, that would be 12. The smallest number that 3 and 4 both divide into. Okay, so we want to combine. We want to build fractions equivalent to these fractions which have denominators of 12. To turn 1/3 into some number of 12, so we have to multiply 3 by 4 to get 12, so we have to multiply 1 by 4 to get 4. 4/12 is equivalent to 1/3. Now subtracting. 3/4, we want to get a fraction equivalent to it with denominator 12. To go from 4 to 12, the denominator was multiplied by 3, so the numerator must also be multiplied by 3. Okay, now let's look in the numerator. We have 3/6 plus 4/6. That's 7/6. Once you have the same denominator, you can add fractions by adding the numerators. And the same thing for subtraction. The same denominators, you subtract the fractions by subtracting their numerators. 4 minus 9 over 12, which is minus 5 over 12. Okay, now, how do we divide fractions? We invert and multiply. So instead of 7/6 divided by minus 5/12, we're going to make it 7/6 times 12 over minus 5. You can put the minus sign either in the numerator or the denominator, or just keep it in front of the fraction. Okay, so 7/6 divided by minus 5 over 12. We invert and multiply by 12 over minus 5. Now, 6 goes into 12 2 times. 7 times 2 gives us 14. 1 times minus 5 for a final answer of minus 14/5, or 14 over minus 5, however you want to write it. It can be either minus 14 over 5, or 14 over minus 5. Multiplying fractions by multiplying the numerators and dividing by the product of the denominators. This is one way of handling it. You work with the numerator separately, add the fractions in the numerator. Okay, work with the denominator separately, combine the fractions in the denominator, and then divide by inverting and multiplying. Let's do the same problem now by another technique. Method 2. 1/2 plus 2/3 over 1/3 minus 3/4. What we're looking for now is the least common denominator from all the little denominators, okay, the minor denominators in the problem. Okay, I realize for the entire problem this is the numerator, this is the denominator, but what I'm talking about now is look at all the little fractions and look at their denominators. 2, 3, 3, and 4. We want the smallest number such that all of these numbers divide evenly into it. Okay, and the smallest, the lowest common denominator in this case would be for 2, 3, and 4 would be 12. You can indicate this, say, the least common denominator or the least common multiple of the numbers 2, 3, and 4. The smallest number such that 2 goes into it evenly, 3, and 4. They all divide without a remainder. Okay. Once you've found that, and you can always, in a pinch, you can take the product of the denominators. That would be something that would work. It's a common denominator. It wouldn't be the least common denominator, but it would be something that would work in this case. If you use something a little too large, your final result will have to be reduced a little further at the end. Okay, but in a pinch, you can use the product of the denominators. 2 times 3, 6 times 4, 24. It's not the best you can use. In this case, 12 covers you. But if you use 24, it would not be catastrophic. And the trick is to multiply numerator and denominator of this fraction, okay, by this number 12. Remember, it's perfectly okay to multiply the numerator and denominator of a fraction by the same non-zero constant. This gives us an equivalent fraction. So this is what we're going to do. Now, we're going to use the distributive law. If you multiply 12 by 1/2 plus 2/3, that means 1/2 gets multiplied by 12, and 2/3 gets multiplied by 12. And here, 1/3 gets multiplied by 12, take away 3/4, which gets multiplied by 12. In other words, each and every fraction is going to get multiplied by 12. You're going to distribute the 12, so it multiplies 1/2, 2/3, 1/3, and the minus 3/4. Okay, now let's see what we have. 2 goes into 12 6 times. Okay, so we get 6 for that. 3 goes into 12 4 times. 2 times 4, that's 8. 3 goes into 12 4 times for a 4. Now 4 goes into 12 3 times. 3 times 3, that's a 9, and you're subtracting. And you get 14 to the 6 plus 8, 4 minus 9 minus 5. The same answer that we got using method 1. Okay, by the way, in these multiplications here, when you're multiplying by 12, you're really multiplying by 12 over 1. So you multiply the numerators and divide by the product of the denominators. It's the same all the way through. Okay, let's just look at the two methods again. In the first one, method 1, we work separately with the numerator, combine over the lowest common denominator for the denominators in the numerator here. And that's 6, we combine over 6. In the denominator, we combine over 12. We add the fractions to the numerator, we subtract them to the denominator, we invert and multiply to finish off the problem. Here we just decide right away for all the little fractions, okay, for all these little denominators, these minor denominators, what number will, if you multiply by what number would you clear all of those fractions? And having decided on that number, you multiply numerator and denominator of the fraction by that number. You distribute it. Remember, don't make the mistake of going 3 into 12 goes 4, and then you only have a 4 left for the 1/2. It doesn't work that way. First, actually multiply the 12 all the way through, and then do your simplifications. Okay, now this was an arithmetic fraction. Let's work out a problem similar to this, but one in which we have variables as well as constants in here. okay, an algebraic fraction. The ideas will be the same. Generally, method 2 requires a little bit more work. Sometimes they're about equal, and in rare cases, method 1 is easier. Okay? If you can get 1 working well for you, you can just use it all the time. But I will illustrate today both methods for the problems. Okay, let's try this. 1 minus 3 over x plus 2 over x squared divided by 1 minus 2 over x. I'm going to do this both ways. Let's start with method 1. In method 1, we work separately with the numerator and the denominator. Okay, let's look in the numerator. This is really 1 over 1. The least common denominator for 1x and x squared would be x squared, the smallest expression that 1x and x squared all go into. And we want to build fractions equivalent to the fractions that we have here, each of which has the denominator x squared. Well, obviously for the 2 over x squared, we don't do anything. Okay, for the 3 over x, to go from x to a denominator of x squared, we'd have to multiply the denominator by x, so you must also multiply the numerator by x. Remember, we're using that fundamental principle of fractions. Whatever you do to the denominator, you have to do to the numerator as well. We multiply the denominator by x to get x squared. We multiply the numerator by x to get 3x. Here, we multiply the denominator by x squared. We must also multiply the numerator by x squared. Of course, x squared over x squared is that 1 that we started with. Now, in the denominator, you can get by with just x. Okay? We want to build fractions equivalent to the ones that are there, each having the denominator x. The 2 over x we leave alone. Here we multiply the denominator by x. We multiply, therefore, the numerator by x as well. Okay? Now, on the top, once we have all the same denominators, we combine numerators. We get x squared minus 3x plus 2 over x squared divided by, here, x minus 2 over x. Okay, and what we're going to do is, instead of dividing by x minus 2 over x, we're going to invert and multiply by x over x minus 2. So we get x squared minus 3x plus 2 over x squared times x over x minus 2. Instead of dividing by x minus 2 over x, we're inverting and multiplying by x over x minus 2. All right? And before we're not just going to multiply the numerators and divide by the product of the denominators. We're first going to see if we can possibly reduce it all. And we notice that x squared minus 3x plus 2 does factor. It factors into x minus 2 times x minus 1. You can check that by FOIL, x squared minus 3x plus 2. We were looking for two numbers which multiply to plus 2 and add to minus 3. And those were minus 2 and minus 1. Okay, and the denominator x squared is x times x. So we have x over x minus 2. Okay, so we can divide. Now everything is factored. We can divide numerator and denominator by x minus 2. We can also divide numerator and denominator by x, giving us, on the top we have simply x minus 1, and on the bottom x for our final answer. And that's as far as you go. You do not cancel the x's, of course, because x is not a factor in the numerator. Okay, here x was a factor. It was multiplied by x minus 1 times x minus 2, and you could cancel the x's. You can't cancel terms, only factors. Okay, now I'm going to try the same problem using method 2. Okay, the problem as it was originally stated. One minus 3 over x plus 2 over x squared divided by 1 minus 2 over x. The least common denominator for all of the little denominators, remember here the denominators are 1. The smallest quantity such they all go into is x squared. We will therefore multiply numerator and denominator by x squared. We'll get, therefore, 1 times x squared minus 3 over x times x squared plus 2 over x squared times x squared. 1 times x squared minus 2 over x times x squared. Each and every term is going to be multiplied by x squared. Now, let's see. 1 times x squared, that's x squared. Here, remember this is really x squared over 1. X goes into x squared, leaving you with just x. You get minus 3x. Here the x squareds cancel, you get plus 2. Down here you have x squared minus, here the x goes into x squared, leaving you with x squared minus 2x. We factor, as we did before, the top factors into x minus 2 times x minus 1. The bottom, x times x minus 2. The x minus 2's cancel. And we get the final answer, the same answer that we got from method 1, x minus 1 over x. OK, now I want to do one more example with you. Once again, doing it both ways. OK, the example is 1 minus 1 over a plus 1 over 1 plus 1 over a minus 1. In all the other examples, method 2, I would say, worked a little simpler. In this particular example, method 1 is going to be the easier technique. All right. This is really 1 over 1. 1 over 1. In the numerator, the lowest common denominator is a plus 1. The second fraction we leave alone. The first, we have to multiply the denominator by a plus 1, so we multiply the numerator by a plus 1 as well. In the denominator, we combine over a minus 1, the second fraction leaving alone. The first one, you multiply the denominator by a minus 1, and the numerator as well. Now, a plus 1 minus 1, that's just a, over a plus 1. A minus 1 plus 1, that's just a, over a minus 1. Okay, we can, instead of dividing, we invert and multiply a over a plus 1 times a minus 1 over a. The a's cancel for a final answer of a minus 1 over a plus 1. We have 1 minus 1 over a plus 1 over 1 plus 1 over a minus 1. Now the lowest common denominator for all of the little denominators would be a plus 1 times a minus 1, which, by the way, is a squared minus 1 using FOIL. A squared minus a plus a minus 1. We will therefore multiply numerator and denominator by a plus 1 times a minus 1. It's going to be 1 times a plus 1, a minus 1, minus 1 over a plus 1 times a plus 1, a minus 1, over 1 times a plus 1, a minus 1, plus 1 over a minus 1, times a plus 1, a minus 1. Each and every term is multiplied by the a plus 1, a minus 1. Let's see what we get. A plus 1 times a minus 1, that's a squared minus 1. Here, the a plus 1's cancel, so you have minus, and then in parentheses, a minus 1. 1 times a plus 1 times a minus 1, that's a squared minus 1, plus, here the a minus 1's cancel, so plus a plus 1. Let's simplify a squared minus 1. We have to distribute a minus 1 through the parentheses. Minus 1 times a, that's minus a. Minus 1 times minus 1, that's plus 1. Down on the bottom, a squared minus 1 plus a plus 1. On the top, minus 1 and plus 1 add to 0, and they cancel out. So we have just a squared minus a. Combining like terms on the bottom, we see we have just a squared plus a. Once again, the minus 1 and the plus 1 add to 0. Don't think that I canceled this minus 1 with this and this with this. The top, the minus 1 and the plus 1 gave me a plus 0, and on the bottom, the minus 1 plus 1 gave me a plus 0. Now I can factor an a out of the top and an a out of the bottom as well. The a's will then cancel, giving me the final answer, a minus 1 over a plus 1. So while in the first two examples, method 2 was easier, in this example, certainly it seems that method 1 had the edge. Of course, it's only important that you know one way of doing it, and I'll leave it up to you which one you like better. Okay, and that brings us to the end of the tape.